Welcome to qnawire.
So we have a copper pot with water, and then a block of iron is being put into it. So we can say that Q gained, and this would be energy gained, thermal energy gained by the water in the copper pot, would be equal to the thermal energy lost from the iron block. So we can say that the mass of the copper times the specific heat of the copper times temperature minus temperature of the copper initial plus the mass of the water, specific heat of the water, times the temperature minus the temperature of the water initial. This is going to be equal to the mass of the iron times the specific heat of the iron times the temperature, times the change in temperature of the iron. That's 85 degrees Celsius, which will be the initial temperature of the iron minus T, the final temperature of the iron. So at this point, we can actually solve and say that this is going to be 0.5 kilograms times 390 joules per kilogram per degree Kelvin, or rather per Kelvin, times T minus 20 degrees Celsius plus the mass of the water, so 0.17 kilogram, times the specific heat of the water, 4,190 joules per kilogram per Kelvin, times T minus, again, 20 degrees Celsius, is going to be equal to the mass of the iron. So this would be 0.25 kilograms times 470 joules per kilogram per Kelvin. This would be the specific heat of iron, times 85 minus T once again. And you can use the solve function in your TI 84, 85, or 89 in order to solve for T. Simply drop the units, and then essentially you can substitute T for X and just solve for X. And we find that the final temperature of the system is going to be equal to 27.45 degrees Celsius. So after the iron block is dropped and the system reaches equilibrium, the final temperature is again 27.45 degrees Celsius. That is the end of the solution. Thank you for watching.